Hello, viewers. Welcome to another wonderful episode of Mindspring Academy. So, today we're going to be looking at physics, and here the topic we'll be discussing is scalars and vectors. Now, before we proceed, there are actually quantities in physics which can be classified. The first one is we have the scalar quantities. Now, what is scalar quantities? Scalar quantities are those quantities which has magnitude but no direction. All right. Now, many students have asked this question. And what is that? What is the meaning of magnitude? Now, sometimes they might ask you find the magnitude of the force. You're meant to find magnitude of the force. Now, students will get confused. Don't get confused. Magnitude simply means how big, how voluminous a particular thing you are asked to find is. So when they ask you find the magnitude of the force, let the magnitude not confuse you. They're trying to ask you, is it going to be 50 Newton? Or is it going to be 30 Newton? Or is it going to be 20 Newton? Things like that. That's what I mean by magnitude. Okay, one more thing you need to note is with scalar quantity can be added by algebraic methods. Alright. Now the next one is going to be vector quantity. I'm going to still give you examples on scalar quantities, but I want us to take it in mass. Let it be many, not just few that you should know. So the next one is vector quantity. Now vector quantities are those quantities which has both magnitude and direction. Now vector quantity again can be added by geometrical methods. All right. Now looking at this, what we're saying in essence is vector quantity are those quantities which has both magnitude and direction. Now when you call something a vector, you should know that the symbol for vectors is a line with an arrowhead. Just as you can see, a line with an arrowhead. Now here they can actually give you 5 Newton. It will tell you a 5 Newton force. So meaning that this is actually a vector. When you see an arrowhead, it shows a vector. Now let's go over to the examples, the massive examples of scalar quantities and vector quantities, which you should know. Now, when it comes to this, the first thing you need to know is there are some quantities that are actually scalar. Not all quantities in physics are scalar. We have the scalars and we have the ones that are vectors. So take note. Now, examples of the scalar quantities are we have the length, we have time, we have mass, we have energy, we have temperature, we have volume, we have frequency, we have direct current. Now, someone might ask, what about direct alternating current? That is another type of current we have. Direct current is the one that is scalar. Now, the reason is because it does not periodically flow back. That is for direct current. So this, go over to speed. This is speed. This is amount of substance. Luminous intensity, use SI unit is candela. So go back to my other video. You're going to see where we made a video on fundamental and derived quantities. The next one is density. The next one is work. The next one is pressure. The next one is power. The next one is charge. Why this is entropy. This is concentration, this is refractive index, and this is electric potential. All right, now if you look at this now, I just want to give you something. It's like a tip on how to identify. Now, from our last video, you notice we have two types of quantities also. Two types of quantities, which is fundamental quantities and the derived quantities. Now you notice something here. all fundamental quantities are actually scalar quantities. That's how to derive it. Now, some other thing again I want to say is this: apart from energy, work, apart from energy and work, any other thing that has and power, any other thing that doesn't have force is actually meant to be under the scalar quantity. What do I mean by that? Look at definition for speed. Even from the formula, there is no force in the formula for speed. No force in time, no force in temperature, no force in frequency, no force in current, no force in the formula for charge, no force in the formula for refractive index, and even electric potential. So just 3 or 4 quantities that are actually scalar. The reason is this. Now, if it comes to this is energy. This is energy. This is work. This, let me mark them, this, and this. These are the 3 quantities that can have force inside their formulas, which their formulas are: here is force times distance, here also is the same thing as that of energy, force times distance. So right here we could have force times velocity. Now, the reason for this is, if you look at this, you notice that it's not proper. It's not proper when someone has energy. Then you now say that, yes, it's a vector quantity. It's not actually a vector quantity. It's a scalar quantity. So the one with force times distance, and force times velocity, the 3 quantities are actually meant to be scalar quantities. And here, this is vector quantities. So we're going to take, I think we have up to like 20 formulas or quantities that are involved in vector. So the first one is impulse. The next one is force. The next one is momentum. The next one is velocity. Next one is acceleration. This is displacement. Now, in this displacement, I did not add in scalar quantities distance. So it's just like opposite of displacement is distance. So take note. This one is angle, your angle, the normal theta that you know. This is alternating current. That one I talked to you about opposite of the direct current. Now here is torque of couple. This is weight. This is thrust. This is electric field strength, magnetic field strength, gravitational field, angular velocity, angular momentum, centripetal force, frictional force, tension, drag force. Now I want to tell you something. When it comes to vector quantities, just take note of this also as a small idea of quantities. Now here we have field, field, and field. These are the 3 major fields we have in physics. We have the electric field, we have the magnetic field, and we have the gravitational field. So please take notes. Anytime you are giving field in options, just ensure and just know that it's meant to actually be a vector quantity. Is that clear? Now here is vector representation. Now in vector representation, we try to see ways by which you can actually represent a vector. Now here they say the vector is represented with a straight line whose length is proportional to the magnitude of the vector and an arrowhead which indicates the direction of the vector. Now that simply means that when you have something like this is not actually a vector. Now before you can call it a vector is you must make sure that it has what? An arrowhead. Did you get what I said? You must make sure it has an arrowhead. Now let me give examples. Like here we have examples. So I'm going to take the first one, A. Let's take example A. Now if you come to example A, what is this diagram saying? You can tell me. Okay, here the diagram is actually talking about, we can call here from here to here is the length L. But this is actually facing due north. I hope you remember your cardinal points. Where we have north, we have east, we have west, and we have south. Now, all of these is the cardinal point. So whichever one it goes to, we have this, we have this, we have this, we have this. So if you watch, this is pointing to the north. So I'll just come here and write north direction. So now you can have a magnitude for this, and the magnitude you can have is, maybe you will be writing 20 Newton. Now let's assume something, because they said it's proportional to the magnitude of the vector. If this can be called 20 Newton, are you aware that from here to here, which is longer than this. I can't call it 20 Newton again. Maybe I can be putting 50 Newton here. Why? Because it's more bigger. So the more your magnitude is, the more the length of your vector. Let's take question B. How about this? Try it out yourself. If you have this, what direction is it going to be? I guess you got it. Now it's going to be what? East. It's going to be east. Now why? Because when you look at your cardinal point, it's facing towards the right hand direction. So that is meant to be called east. Now what about this? If we have C, let's take another example. And we have something like this. You have a dotted line, and then you have this going out. This is your vector, and you have here, you have 50 degrees. This place is meant to be or not. Actually, if you watch your cardinal point, you see it. So the answer to this for this vector is going to be what? Can you tell me? The answer for this vector is going to be north 50 degrees east. Now why is it east? Watch this. If you draw this, you have east there. Am I right? You have east. So if you watch your vector came out from, and watch, one more thing, for those who are doing mathematics and the rest of them, you must take note of some certain things. There is no way, watch, this is 50 degrees. There is no way you can tell me this will be east, 50 degrees north. It's not possible. This is wrong. It must always start from the north and end either towards the east. That's why it's called north, 50 degrees east. Now, this is addition of vectors. Now, when it comes to addition of vectors, we said the sum of two vectors is called resultant R. Now, whenever you add two vectors, it tends to give you a value, and that value is what we call resultant. In some other places, they can tell you resultant is a single force which will have the same effect as two other forces. So it's just like when you get 2 and you get 3 and add them together, you get 5. What 5 can do, 2 and 3 when combined together can also do the same thing. So here, the resultant when the angle between them is 0 degrees or 360 degrees, that is same direction. What do we mean by that? This is angle 180, angle on a straight line, while this is also angle 180. Sum of two of them should be giving you 360. Now their resultant is going to look like this. The resultant on the body is going to look like this. We have a very long one where we can call it R is equal to P plus Q. So you are adding when the direction are the same, if they move in the same direction. But if they don't move in the same direction, just like number 2, when the angle between them is 180 opposite direction, therefore the resultant on the body is actually going to be this, where we have R is equal to, the biggest one here you can see is P, while the smallest is Q, so P minus Q. Looking at parallelogram law of vectors, this law states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the resultant of the vectors is represented by the diagonal of the parallelogram drawn from point of intersection of the two vectors. Now, this is not actually difficult. All you need to do is you come and we have, for instance, we can have that of acute angle. You can have it when it's in an obtuse angle. And remember, an acute angle is an angle less than 90 degrees. So we could have this. These are two vectors. Have this. Remember to put your arrows, this arrow. Now, if you look at this, I can trace them. And I'm going to form a parallelogram here. I'm going to have a parallelogram. Now, you might have an angle theta that are combining or in between the two forces you were given. Take for instance 8 Newton and here 6 Newton. Now, if you look at this, from our definition, they say they are represented by the adjacent sides of a parallelogram. These are the adjacent sides of a parallelogram. If you write here 8, I hope you know that here is also going to be 8. And here will be 6 Newton, one property of a parallelogram. Now they said the diagonal Diagonal would come from here always. Diagonal will come from here, the angle where it's inclined, and you have your angle R. You have your resultant R. Now, if you have your resultant, that is what they say, that the diagonal of the parallelogram drawn from points of intersection of the two vectors will give you your resultant. Analytical method of resolving or finding resultant vectors. Now here we have, by analytical method, the resultant R and some angles of importance can be calculated with the use of cosine rule. Now, mind you, in mathematics, we have cosine rule and we have sine rule. Now, coming to this, the cosine rule is very, very important and critical in finding resultant. I have my angle theta here. Mind you, here will be alpha, and mind you, the angles at the adjacent sides are equal to each other. You see what I'm doing? This is equal to this is equal to this. And remember, when you sum up something of a quadrilateral, four angles, you should be having 360 degrees in total. Now, the formula according to this is going to be r squared, which is your resultant. R squared is equal to a squared plus your b squared minus 2ab cos alpha. And mind you again, if you come to this, we can actually cut this triangle. If you look very well, you see that this parallelogram is divided into two triangles, whereby we can have something like this. We have this dotted lines. I'm trying to take this triangle, and I have this. So here I have, that's my R, which is the resultant. I have this, and I also have a value here. So here, assuming here is still B, here is still A. So you now have, watch, you're going to notice that only the alpha would remain. But because of what I did here, I cannot actually come and call this half theta or theta over 2. No, it's just like you don't actually know whether it was divided, whether this line divided the theta into two equal parts or not. Here, we have example 1. Let's see an example. An object is acted upon by two forces of 5 Newton and 12 Newton. Calculate the resultant of the forces. If, question I, the forces act perpendicular to each other, the two forces act at an angle of 40 degrees to each other, and number 3, the forces act at an angle of 125 degrees to each other. Now, the first one I'll start with is the one of perpendicular. But mind you, when you hear the word perpendicular, what comes to your mind? Okay, it's going to be 90 degrees. Very good. So here we have this. I can draw this, and I'll have this. So here I'll have 12 Newton, and here I'll place 5 Newton. Remember to add your arrows. Remember to add your arrows. That is actually what makes it vectors. So I will put angle 90 between them. They say to each other. They're acting at angle 90 degrees to each other. So the first thing to do here is make use of Pythagoras theorem. Here will be my R, Pythagoras theorem, and it says R squared is equal to, I'm going to be writing 5 squared plus 12 squared. So I have this, R squared is equal to 25 plus 144. So when you add this, what will you have? You have R squared is equal to 169. Therefore, we are asked to find R, not R squared. So I'm going to do something to both sides, square root both sides. And square cancels square root, yes, of course. So R is equal to square root of 169 is going to be what? It's going to be 13. So I'll put Newton because all others are also in Newton. So here it's meant to carry 13 Newton. The second one, which is II, they say the two forces were inclined at angle 40 degrees. This is how it's going to look like. The other one is 5 Newton. Watch this. I'll try to make this a little bit longer because vector is directly proportional to the length. So I'll call this 12 Newton. So when I do this, you have this. This is your parallelogram. Now the next thing is, remember your resultant, like I told you. In your resultant, remember to put your arrows. In your resultant, you are actually meant to, give me one. In your resultant, you're actually meant to take it from the angle that you were given. That's where you're meant to take it from. So here will be our R. I can decide to label here as A, label here as B, so we don't forget from the cosine rule. Here will also be 12 Newton, which is B. Here will also be 5 Newton, which is A. Now, the next thing to do is, remember, this and this will be equal to each other. Well, how do I find here and here? Very simple. What I'm going to do, I'll call here X, call here X. Why did I label them X? They are both the same thing. So here I have 40 plus 40 plus X is equal to 360. Sum of angles in a quadrilateral. So here we have 80 plus 2x is equal to 360. On the like terms is going to be 2x equal to 360 minus 80. So we have 2x is equal to 240. So I'll divide both sides, and this should be 280. Divide both sides by 2. This will cancel, therefore my x is equal to 140 degrees. So when I place 140 here, definitely I will also be placing 140 degrees. When you sum, you return back to 360. Now remember your formula, r squared is equal to a squared plus b squared minus 2ab cos alpha. And mind you, where is alpha? Alpha is meant to be this, not this. This is theta and this is alpha. Don't forget. Now here we have r squared is equal to, what is going to be my a? My a is 5, so I'm writing 5 squared plus 12 squared minus 2 times 5 times 12 times cos. Cos what am I going to put? Very good, cos 140. So here we have r squared is equal to, it's going to give me 25 plus 144. 12 squared, 144 minus, now 2 times 5 is going to give us 10. 10 times the 12 to get us 120. So I will check with this. Now here, most students make this mistake. The mistake is this. Sometimes you tend to press these ones in your calculator. You might get the correct answer, or sometimes it might not be correct. So in order not to take chances, it's always good to actually get them bit by bit. 25 plus this will give me 169. Now the next thing I'm going to be checking on my calculator here with me is minus 120 cos 140. I repeat again, minus 120 cos 140. Now minus 120 cos 140, that is going to be giving me plus 91.93. So when you add it up, you have r squared is equal to, sum these two up, it's going to give us 260.93. How do I find my r? Very simple. I will square root both sides again. Square root both sides. Therefore, square we cancel square root. R is equal to, what's the square root of 260.93? You can check as well with me. So it's going to give us 16.15. I'll put my Newton, and that becomes my answer for resultant of the second question. Over to the third one. The third one says when they are at an angle of 125 degrees to each other. Now I cannot get 125 like this. No, I can't get it. So the best thing I'm going to do is I'm going to have this and I'll have this. Watch this very well. So here being the longest, I can call it my 12 Newton. Mind you, you can put your 12 here, you can put your 5 here, whichever place you choose to, you can put it. So I'll roll this up, take it down, put my arrows. Here is 5 Newton and here is 12 Newton. So the angle between them, listen, the angle between them is 125 degrees. Now to find your resultant, where should I take it from? Should I take it from here or I should take it from here? Let me know if you're listening. Now here, it's wrong. I can't take my result and draw my line through this. Why? I said it is where the two forces, the angle that you were given is coming out from. So I'll draw this to this place. So here to here, I have 125 degrees also. Adjacent angles are equal. And this, how do I get it? Let me show you a more shorter way. Now, a more shorter way is this. 180 minus 125. That's going to give us how many? It's going to give us 55 degrees. So therefore, here also will be 55 degrees. And I can call this R, my resultant. Now looking for it, I have R squared is equal to, remember the formula, minus 2AB cos alpha. So we have our resultant R squared is equal to, what is going to be this? Here is 5, here is also going to be 5, and here will be 12 Newton. Mind you, where they are facing, both sides will be equal. So for A squared, I can choose to take 5 squared plus 12 squared minus 2 times 5 times 12 cos what am I going to take this time around? Please watch this. This is the angle theta, but this one will be my alpha. The reason being that this, I don't know whether it was cut in between, exactly in between 125. I'm not aware of that. It's an angle that you can find. It's just like saying you're finding the direction. That's when we're going to be using this. But because of this, here is my alpha. It's going to be the alpha, one you did not touch or you did not cut your resultants from. That will always be the alpha. So we have cos 55 degrees. So here I have r squared is equal to, still that same 25 plus 144 minus 120 cos 55 degrees. Now here r squared is equal to, this is going to be 169. Now let's check. Minus 120 cos 55. Minus 120 cos 55. All of them in total should be giving me, I think cos 55 will be, I'll put my minus, bring down the 120, cos 55 is 0.574. Yes, that's what I have here. So when you multiply this and this, you'll be having r squared is equal to 169 minus, let me check this, 169 minus 120 times 0.574. That should be giving us 68.88. When you subtract, you have r squared is equal to 169 minus 68.88. I'll be giving you 100.12. So to get your r, square root both sides. Square root cancel square root. So r is equal to, what's the square root of this? It's going to be giving me approximately 10 Newton. Let me check. So be sure of what we're saying. Square root of 100.12 is 10.005. So with this, I can approximate and call it 10. Now if you call this 10, there is actually what we call direction. If you want to find direction, right, to find direction, which you can also do in the II question that I gave you, right? To find direction, use sine rule. To find direction, use sine rule. Now in the sine rule, we're going to be using, remember the formula which says A over sine capital A is equal to B over sine capital B. And decide to call here A, here also will be A. If you call here B, here also will be what? B. Now let's see it together. Now if I come to this, I'll first of all tell myself this and this. I'm looking for, I know the resultant now. So I can use this and this. Or better still, let me bring it out very well. You have this, you have this. Trying to bring out one of the triangle. So I have here as R, have here as 55 degrees, have here as, I'll call here my theta, because I don't really know what value it was in. I remember saying something about getting it from the angle you were given, but you don't know if this was divided equally. You never can tell. So let's find out by ourselves. Now the next thing I'm going to be doing is, what is my A? This is my A. My A is this, 5 Newton. So I'll be writing 5 over sine. Did I know the value for this? I don't really know the value. Look at it here again. I don't really know the value. So what I'm going to be doing, I'll write sine theta is equal to, what is the other one? What's the other one going to be? I'll be using, because of this, you have this and you have this again. So you can find two things. I'll be using sine my alpha, and then I'll call here r. What I mean by that is this. This is the r where the angle is facing, and with this, you can actually get our answer. So I'm going to be having the resultant 10, which is the resultant 10 over sine, what's my alpha? Is sine 55. So with this, I can cross multiply. You cross multiply, you have 10 sine theta is equal to 5 times sine 55. So we are dividing both sides by 10. This we cancel this. So therefore, sine theta, let me bring it out here. Therefore, sine theta is equal to, is going to be 5 times, let's see what is sine 55. Sine theta is equal to 5 times this sine 55. Let's see it. Sine 55 will actually be giving me 0.819. Yes, 0.819 over 10. So finally, my theta, the value theta is equal to, is going to be sine inverse. Sine inverse, let me put it here. Theta is equal to sine inverse of, if you press it, 0.819 times 5 over 10. Please, mind you, don't press everything once. If you press it once, you might get a different answer from what you're meant to get. So this, you press 5 times 0.819 first, and then divide it by 10. So that will be giving us 0.4095. I'll put it in bracket. So when you find the sine inverse, that should be giving you your theta, which when you press it, sine inverse of this, that is 24.17 degrees, and that becomes your answer for the direction. All right, this is actually where we're going to stop. So if you know that this video was helpful and you really liked it, give it a thumbs up, like, share, subscribe, share to those who actually need it. Don't keep this knowledge to yourself, you know what I mean. All right, now we're going to be looking at a very critical aspect of scalars and vectors still. Here we have resolution of vectors. Now, resolution of vectors is the process of finding two vectors which have the same effect as the resultant vector. The components of the vector are usually two perpendicular axes, namely vertical direction and horizontal direction. Now take a look at what I'm going to be doing. I have this and I have this. Here is called y-axis. Am I right? While here is called x-axis. Let's put it plus and let's put it plus. There's a reason for that. We're going to see it also. Now this is the origin, 0. Now assuming you have an angle, that is inclined with y and x. I'm going to put here, I'll call here theta and I'll call here alpha. Meaning when you combine both, you should be getting, I think, 90 degrees. But I want to separate actually. I'll be having theta and I'll be having alpha. So the next thing to do is called, I'll call it V. Let's see this. From here to here, I'm going to call it VY. Why? Because that is the component, the vertical component of this V. Why here to here, we have VX as the horizontal component. Now, mind you, if you have something like this, if you try to trace it down, you're having something like this. So with this, let's see something. Here is going to be my opposite. Am I correct? Here is going to be my hypotenuse. And here is going to be my adjacent. But mind you, we have a target. If here is VY, are you aware that here also will be VY? And if here is Vx, here also will be Vx. Get it? Okay. Now look at this. We're going to look at this opposite and hypotenuse. I want to do the vertical component. So I'm going to write vertical component of V. I decided to make use of the letter V. It's my choice. Vertical component of V is going to be, I'm taking the vertical, which is the one that has Vy, not the Vx. Vx will be the horizontal. I'm taking the Vy. What I'm going to be having is opposite and hypotenuse. So therefore, I'll be writing, first of all, let me show you how it's gotten, and then we can now figure it out the rest. Figure out the rest by ourselves. Let's go. So here, opposite and hypotenuse, I should be using the trigonometric ratio sine theta is equal to opposite is Vy over your V, which is your hypotenuse. When you cross multiply, you therefore have that vertical component you were asked for. So which will be V sine theta. So let's put it here. I'll write Vy is equal to V sine theta. You get this? So let's go to the next one. If you look at the next one, we have number 2. Let's see how we can get the one that has alpha. Now, if you look at the one for alpha, you focus on your Vy, not the Vx. Focus on your Vy. So you're having here as adjacent for this alpha. While where the alpha is facing is the opposite. Here remains your hypotenuse. So let's go. I'm using adjacent and hypotenuse. I am not doing horizontal components. I'm still on the vertical component. So this is adjacent and this hypotenuse. So I can write number 2, Vy. Another way I can get Vy is by saying V sine. Is this sine or cos? It's meant to be cos. Why? Adjacent Vy and your hypotenuse, which is letter V. It's going to be V, V cos what? Alpha. Now help me and let's see if this can be done. Horizontal component of V. Let's see it. Number 1, the first one. Can we try? If you look at this, this will just be like opposite of it. So here is Vy, here is Vx. I'm going to put V. This place is sine. It will be opposite of it because opposite of vertical is what? Horizontal. So it's going to be V cos theta. While the other one, still the same Vx, will be V sine alpha. That's what it's going to be. Vx is equal to V sine alpha. And let me show you where it's coming from. It's coming from this. If you look at this, we're focusing on this now. So here is adjacent and here is hypotenuse. Remember, it's theta. So adjacent and hypotenuse, what trigonometric ratio are you supposed to use? It's meant to be cos. While if you come to this side, you're looking at the opposite and we're looking at the hypotenuse with the alpha. So opposite and hypotenuse, where is it meant to be? It's meant to be sine, the trigonometric ratio you're going to be using. All right, thank you. In our next class, we're going to give questions. That should be the next thing. Give questions on how to find resolution of vectors that are more than one forces or two. What I just did is for one. For one, that is what I did. So now we're going to, in the next class, look at different forces and how it can be solved and tackled. Welcome to this wonderful episode of resolution of more than two vectors. Remember to like, subscribe, tap the notification bell so that you can be notified when we upload new videos. Alright, now here we have resolution of more than two vectors. If you come to this is vector f1, is vector f2, and remember I told you that vectors are meant to be noted with arrowheads, and this is vector f4. Now the first thing I'm going to do is to try and resolve them. Don't forget the question I did, the one of one vector, where we had something like this. We had v, we had theta here, so which I drew something like this, and I said here is vx, here is vy, here is also the vy. When you roll this up, here will also be vx. That is the same pattern we're going to be using here. Now, if I try to draw this way, mind you, this is positive y, this is positive x, this is negative x, and this is positive y. Negative y, sorry. Now, in this, we have all our axes well written. So the first thing I'm going to do here is, I'm going to look at this side. If you watch, here will be my opposite. But what it is facing is positive y direction. So it's either I will go ahead and look for the horizontal component or the vertical component first. But mind you, the horizontal component is always the x-axis and vertical is the y-axis. So let's do it together. I want you to follow me. There is opposite and y here is hypotenuse. And your hypotenuse value is f1. So if you look at this properly, you're going to see that. Let me clean this. So with this, we have f1 being the hypotenuse. There is opposite. I want to find, let me find horizontal components. This is the horizontal. Hope you get what I'm saying. This is the horizontal. So here, for the horizontal, is already in positive x direction. Is in positive x. So I will be saying adjacent, because here will be my adjacent. Adjacent and what? Hypotenuse. I don't have a value for opposite. Hypotenuse is your f1. So adjacent and hypotenuse, because I'm looking for the horizontal component. So if I do that, I'll be having cos, because of adjacent, cos theta 1 is equal to, I'm not going to take all of them the way I'm doing it. I just want to do the first two or first three, and then you do the rest. Now let's go. Excuse me. If you come to this, adjacent, what's your adjacent? Is positive x over, what's the hypotenuse? Is f1. So if I cross multiply, I'll be having that x is equal to f1 cos theta what? 1. Now if f1 cos theta 1, let's put it there. The first is f1. That's the first one I'm taking. And the angle of inclination is theta 1. So let's see something together. The horizontal, we just rectified it now. I'll be writing f1 cos theta 1. Did you get what I said? All right. Now let's continue. Let's look for this. It's going to be opposite and what? Hypotenuse. Am I right? And opposite and hypotenuse, it should be giving you sine. So I have f1 sine theta 1. Remember, it's still in positive y-axis. And let's go to f2. Let me do f2. Now in f2, if I try to draw this down, are you aware that where your angle is facing remains your opposite still? Good. So here is negative y. Watch. We've come down to where negative y-axis is because of this and this. So we have, this is your hypotenuse. So if I want to get it, I can actually say cos, let me change this to cos theta 2 is equal to, let me look for the horizontal. In this, we're using f2. So cos theta 2 is meant to be adjacent. Look at it, positive x is already there. Over, what's your hypotenuse? Hypotenuse is f2. So you put f2. So with this, when you cross multiply, you have x is equal to f2 cos theta 2. So here I'm going to write f2 as the force. The angle of inclination was theta 2, while this will now be f2 cos theta 2. Remember, it's still on the positive x, but on the negative what, everybody? Alright, now coming over to this, let's see for the vertical component. Now for the vertical component, what we're going to be doing is we'll be making use of the minus y. Remember, the vertical. So if you have minus y, I'm going to be using opposite, watch it here, opposite and hypotenuse. So let's go. I have sine, because of that. Sine theta is equal to theta 2. Let's put it. It's theta 2 we're talking about. So theta 2 is equal to, opposite is minus y over, what is the hypotenuse, everybody? That's going to be f2. When you cross multiply, you have minus y is equal to f2 sine theta 2. But mind you, this is minus y. But what I'm looking for is vertical component y. Here is it, vertical component y. So what I'm going to do, I'll divide both sides by minus 1. Divide by minus 1. So minus will take care of minus. Therefore, y divided by 1, what's it going to give you? Y divided by 1 will give you y. So y is equal to the minus. We have to go to the numerator. We have minus f2 sine theta 2. So I'm placing it here. Minus f2 sine theta 2. Let's see the next one. If you come to this, I will draw this down. Here is still my negative y. Because of this, it's still my negative y. This both sides. And here is going to be my hypotenuse. Here will be my opposite. And here will be the adjacent. So let's see it together. So if you try to do this, it's going to be opposite and hypotenuse. Now, opposite and hypotenuse, I should be using sine. That's if you're doing vertical. But from my table, I think what I have first is horizontal. So let's do horizontal. It's going to be adjacent and hypotenuse. Now, mind you, I will be putting F3, theta 3. So the next thing is going to be F3. But I should be putting minus. Why should I put minus? The x is the negative x direction. So it's going to be minus f3 cos theta 3. I'll still tell you something about this table we're filling at the end of the table. I'll give you a tip or a hint on this. And let's go to the other one. Vertical component, vertical, the vertical line. So it's going to be opposite and hypotenuse. But mind you, the y is also on the negative axis. So what I'm going to be having is, I'll have minus f3. You see what I did? Minus f3 sine theta 3. Minus f3 because of the minus that it's carrying. Let's go to the last one. If I draw this, here with positive y, here is my opposite, here is my hypotenuse, and here remains my adjacent. So I have f4. And for f4, the angle that it's inclined to is theta 4. So let's go. I'm taking the horizontal first. I'm still on the negative x direction. That's the issue we have here. Negative x direction. So I must have to put minus, get this, minus f4 cos theta 4. You see what I did? Now go to the next one. It's going to be opposite and hypotenuse. Opposite and hypotenuse, that should be sine. But what is the y on? Is it on the negative or positive? Can you give me an answer to that? Very good. It's meant to be on the positive. It's still on the positive. So we have f4 sine theta 4. Meaning the next thing to do is to find the summation. Summation is equal to, find the summation of the x-axis, which is the horizontal component, and we'll find the summation of the y-axis as well. Right, now over to this. If you want to add for the x-axis, remember the first one is f1 cos theta 1. I hope you remember. Now the second one is going to be plus f2 cos theta 2. Let's go to the third one. The third one is carrying a negative sign. So for the negative sign, we have a minus f3 cos theta 3. And the last one is also carrying a negative sign, which is minus f4 cos theta 4. Go over to the next one. We have f1, that's for the vertical, sine theta 1, minus f2 sine theta 2. That's the second one. The third one, minus f3 sine theta 3. And the last one is going to be plus f4 cos theta 4. And when you add it up together, you're going to be having your resultant finally as the square root. Where is it coming from? Just like your Pythagoras theorem, square root of r. When you square root r, you have to square root the other side also as well. So with this, we'll have r is equal to x squared plus y squared. That's the values you got from your x and the values you got from your y. X squared plus y squared. And you get your resultant. This is a formula on how to get your final answer. Alright, we're going to see more questions. Remember to like, subscribe, and share to those who might be in need of this. And here in MindSpring Academy, we have a question on resolution of more than two vectors, and it says three vectors, 3 meter per second, not 45 degrees west, 12 meter per second west, and 5 meter per second south act at a point. Sketch the vector diagram and find the resultant. This should be very, very simple. You don't need to stress yourself. First of all, give out your cardinal points. You have here as your north, you have here as your east, you have here as west, and you have here as south. I hope you know about that. I'm going to clean this because I have some values to place there. So I have this, it has a vector, 3 meter per second, not 45 degrees west. Now look up. If you watch this very well, you know that here is going to be your 3 meter per second. Yes. So mind you that they were telling us to use not 45 degrees west. So I have from here, it starts from north and run down to the west direction. So here is going to be my 45 degrees. But I'm not supposed to have an angle inclined to the vertical. It's not inclined to the vertical. It's always meant to be inclined to the horizontal. We're meant to incline it to the horizontal. So can we find the value here? Yes, I know that here to here is 90. Here to here is also 90. Here to here is also 90. So for me to find this, all I need to do is I'll say 90 minus 45. Here will be giving me 45 degrees also as well. Okay, now if you come to this, the next one, let's take the next one, 12 meter per second west. I'm going to be writing my 12 meter per second here. And the other side, I'm going to, because of the south, I write my 5 meter per second. Very simple. Let's proceed. So they said we should sketch the vector diagram, which I've done entirely. And the next thing is they say we should find the resultant. So I'm going to be creating two different tables. And the two different tables is going to be like this, where we have the vertical and we also have the horizontal. We do it here. So we have vertical component, which is your y, and you have horizontal component, which is your x. So let's take the first one. Now, before we proceed, I've noticed something from this question. 1, 2, we're meant to have 3 forces. I've noticed this. Now, what did I notice? I noticed that the vector was inclined directly to the south, and this one was inclined directly to what? West. Now, please, you must take note of this. Note, you can put it down because it's very important. Note, when something is inclined directly to the vertical, when something is directly on the vertical, when vector lies directly on vertical, comma, use theta as 90 degrees. But when vector lies directly on horizontal, use theta as 0 degrees. I hope you get what I said. Now let me show you what I mean by that. Now let's take the first one. I'm going to take for the 3 meter per second. That's what I'm going to be taking. Now for the 3 meter per second, if I do this, mind you, the angle you're using is this and not this one anymore. You're not using this again. So I can decide to clean it. Now using this, here is positive y. That's still going to be my opposite. Here is hypotenuse, take note. And here is what? Adjacent. So here is negative x. Mind you, it's negative x direction. So for me to find the vertical, I'm going to be having opposite and hypotenuse. I'm going to be having opposite and hypotenuse. So this time around, we're no more going to be putting F1, F2, We'll put the value directly because it was given to us. So for the first one, I'm going to be writing 3. And mind you, in vertical, all the verticals must have sine. All the horizontals must have cos. That's just the rule. So all vertical components carry sine, while all horizontal components carry cos. I'm writing 3. But the 3 I'm writing it as positive because the y is at the positive side. This y component is at the positive. So I'll be writing 3 sine 45 degrees. That's what I'll be writing. Now let's see the horizontal. And now for the horizontal, it's going to be adjacent, which is carrying negative. And then this is your hypotenuse. So what do? We're going to be having minus, because it's on the negative direction, minus 3 cos 45 degrees. That's what you're supposed to write. We are still using 45 degrees. The next one is number 2. Let's take number 2, which is going to be 12 meter per second. Yes. Now on 12 meter per second, what axis is it lying on? It's lying on horizontal. Remember my notes. When vector lies directly on horizontal, use theta as 0 degrees. So therefore, this place, it should not be an issue. Take note of what the x will be. Is it negative or positive? It's still negative. So we are supposed to have on the vertical, because this has no relationship with vertical, what I'm going to be doing now is I will just call it a positive value. Why? Remember, has no relationship. All these things are horizontal. It did not say something like this and cut down. No, it's on the horizontal. So give the vertical positive, because you cannot come and start interfering. It's just like seeing someone who is innocent and say, yes, you are guilty. No, it's x that it's focusing on. So it's only x that should be either minus or plus. But if it comes to the vertical component, you don't put minus for it. Just leave it as plus. Now let's go. Here I'm going to be having 12. I'll write the 12. All right, 12. 12. What's the next thing? Remember your rule. You must have sine inside. And what theta am I going to be using? Since it lies on horizontal, I'm going to be using 0 degrees. Let's go over to the horizontal component. So I'm going to have minus 12 cos. Hope you know why I put minus, because it's on the negative x. Minus 12 cos. Theta c remains 0 degrees. Now quickly, the last one, I'm going to do it in a very special way. And what is that? Now, mind you that we said you must be using sine for all the vertical, and you must be using what for all the horizontal, cos. Now let's go. We said when vector lies directly on vertical, use theta as 90. So I just need to place 90 degrees here, place also here 90 degrees. Now let's be mindful of something. This is negative y axis, while this is positive y, mind you. So this is only the y that has this, the vertical. So the vertical is negative. Vertical is negative. So I'm going to be putting minus 5. You see what I did? And let's go over to the x. I told you when x don't have any, this thing don't have relationship. This has no relationship with x. So we're just going to be writing our 5 directly. Now the next thing is to find the sum. Let's find the sum of all of them. All right. Now finding the sum. Right, now looking for the sum, we have the x-axis, we have the y-axis equal to. Let's do this together. Now if you come here, 3 sine 45. 3 sine 45. 3 sine 45. That's going to give me 2.12. Sorry, I'm writing it on the x. It's meant to be for the... Okay, let's do this. Let's do this so we can put it on the x. Minus 3 cos 45. What's it going to give me? That's going to give me minus 2.12. The next one, I'm meant to put my plus minus 12 cos 0. Minus 12 cos 0. That's going to give me minus minus 12, because cos 0 is actually 1. So when you multiply it, you get minus 12. The next one is still on the x component, is 5 cos 90. Cos 90 should be 0. Okay, yeah. So 0 times 5, that should be giving you 0. So you can write plus 0. Yes, which is this 5 cos 90. When you press it, the answer will be 0. Let's go to the y-axis. Now for the y, we have 3 sine 45. It's going to give you 2.12. Next one, plus this is 12 sine 0. Sine 0 is actually 0. So 0 times the 12 is going to give you 0 plus, open bracket, this is minus 5 sine 90. Sine 90 is 1. So minus 5 times the 1, that will give you minus 5. So I'll do this. So finally, my x is equal to, let's add all of this. Or better still, I should do it like this. Put it like this. So minus 2.12 plus times minus is going to give us minus. So minus 2.12 minus 12. That will be minus 14.12. Yes. This one, let's do it together. 2.12 minus 5 is going to give me minus 2.88. Am I correct? Yes, I'm correct. Minus 2.88. So the next thing is, let's find a diagram for this. Remember, the x-axis is saying negative. So negative direction for x is this direction. I'm going to put 14.12, 14.12, 14.12. While the other side, I have minus 2.88, minus 2.88. Okay, let me reduce this. The negative sign is just showing us, I'm reducing this because the value is small. Negative sign will just have to show you where it's going to be. This is negative y-axis and this is negative x-axis. Take note. So we're meant to just put 2.88. So if I put my resultant, that's the next thing to do. I'll place my resultant. So from the resultant, I can say r squared is equal to 14.12 squared plus 2.88 squared. So r squared is equal to 14.12 squared. That's going to be giving us 19,199.4 plus this squared will give us 8.3. When you sum it up, what we're going to be having is 207.7. So I'll square root both sides, square root here too, square we cancel square root, therefore r is equal to, r is going to give us 14.41 meter per second. Again, you can be asked to actually find direction. And when you ask to find direction, put your direction here. So you call it theta. Why did I put the direction here? Why did I start from here? I didn't do it here. The reason being that this is south. You always have something like south, 50 degrees, maybe west or east, any of them. Something like this. But I think this should be west because of this. South going to west. So you start your angle from here. That's the rule. You start it from here. So now looking at this, I'll be having opposite over hypotenuse. And this will be my opposite. Sorry. Here is my hypotenuse. And here is my adjacent. So opposite over adjacent. What is it going to give me? I'll be using tan theta to find the direction. So what's tan theta is going to be 14.12 over 2.88. So which is equal to, when you press that, that should be giving you 4.93 as still your tan theta. We say theta is equal to tan inverse of 4.93. And the tan inverse of 4.93, theta therefore finally going to be 78.5 degrees. That becomes the direction. Yes, the direction for this resolution of more than two vectors. All right. The next thing is I would like to give you a question. Try this out. So how do you do it? You're going to drop it for me on the comment section. Drop it for me, your final answer on the comment section. Do this, try it out, and then drop your answer in the comment section. Bye bye.